So this is going to be a video of the lesson 7 homework and the lesson 8 homework. Again, stop it at any time that you need to, just so that you can copy anything down or fix anything on your paper. We might have done the lesson 7 homework question 1 and 2 in class already, so I'm just going to do those kind of quickly. So the first question in a circle, in question 1, we have circle C. This line right here is tangent. I know that this is an isosceles triangle because these both are radiuses of the circle. So since those are congruent, then these angles have to be congruent. So if this is 28, that has to be 28. I just add the 28 and the 28 and I subtract from 180, and angle C is 124 degrees. Now if angle C is 124 degrees, that makes this arc right here 124, because angle C is a central angle and the arc is equal to that central angle. And then they want me to find, they want me to explain why angle DAB must equal 62. So angle DAB is right here. So this is not an inscribed angle, but it has the same rule as an inscribed angle, that it's half the arc. So since this arc is 124, that's just going to be half the arc. We also did number 2 in class, but if you need it again, these arcs are in the ratio 2x to 7x. So all I do is I want to find angle P out here. I need to find those arcs though before I do any of that. So 2x plus 7x plus 82 plus 98, because they gave me these other arcs of 82 and 98. All together, all 4 of those arcs form a complete circle, so they equal 360. So I'm just solving for x. Once I find that x is 20, I can actually find this arc. I cannot find angle P if I don't know what the arcs are. All I knew is that they were in the ratio to 2 to 7. But now that I solve for x, I know that x is 20. 2 times 20 is 40, and 7 times 20 is 140. So when I find angle P is outside the circle, and that angle is equal to 1/2 the difference of the arcs. So I just subtract those arcs and take half of that. Question 3, they gave me some arcs. That angle NPQ is 102, so that makes this arc right here in green that I have highlighted 204, because this is an inscribed angle and the intercepted arc is twice the inscribed angle. Angle M, which is right here, is 60, and I want to find the length of PR. So angle M is an angle that's outside the circle, and the rule is it's 1/2 the difference of the arcs. So all I'm doing is I'm doing 1/2 of 204 minus x. It's always the bigger arc minus the smaller arc. You can see I have those highlighted, so you can see where I'm getting those numbers from. To get rid of the 1/2, I'm multiplying by 2, so I multiplied this 60 by 2, and that's where the 120 came from. And then I'm just solving for x, and I get 84. And arc PR is what I wanted to find, and that was my x. So next page, question 4, starting to look a little bit more complicated here. But angle FBC is 52. Since that's 52, I know that this arc that I have highlighted in yellow is 104. And they also they told me that arc BE is 138, so I know that. And I want to find the measure of arc BF. So this arc BF right here is, first of all, I know that arc FC is 104, and together these arcs form a half a circle. I know that because BC is the diameter of the circle. So 180 minus 104 is 76. And if this arc is 76, then this angle right here is going to be half of that. That's how I get the 38. But they actually want me to find angle M right here. So angle M is 1/2 the difference of the arcs, because angle M is outside of the circle. So it's 1/2 the difference of the arcs. Which arcs? This arc right here, which is 138, and this arc right here, which was 76. In part C, they want me to find angle BGE. So BGE is right here. That angle's inside the circle, so the rule when it's inside the circle is it's 1/2 the sum of the arcs. Which arcs? The arcs that are on either side. So I have arrows pointing to what arcs that I want to add. So I add those arcs and then I take half of that, and angle BGE is 121. And then that last question, I want to find the measure of angle MFB. So MFB is this angle right here, and it's 1/2 of this arc. The arc is 76. Actually, let me just see. MFB. Oh no, because that's sticking outside the triangle. So angle MFB is actually part of this triangle. Since I know that this is 38 and I know that this is 31, I'm just going to subtract from 180, and that's how I got the 111. In number 5, I have another ratio problem. Those arcs are in the ratio of 2 to 1. So I have them labeled on my picture, 2x and 1x. Together they form a half a circle, a semicircle, because this BD is the diameter. So I set up an equation where I set them equal to 180 to solve. Once I solve for them, I go back and plug in. So this arc is 60 and this arc is 120. I want to find angle P right here, which is 1/2 the difference of the arcs. The arcs are 120, and then this arc right here was 74. So I'm just subtracting them and taking half of that. And then for angle the B, I want to find angle CFD. So CFD is right here, and that's an angle that's inside the triangle. So that is 1/2 the sum of the arcs. And the arcs are the 60, which is right here, and this arc, these arcs together, which are 148. So 1/2 of 60 plus 148 is 104. Then they want to know if AE is perpendicular to PEC at E, and it is not perpendicular, even though it looks like it might be, because I know that angle AEC is 1/2 of these arcs. So 1/2 of AB plus BC is 74 plus 120, and half of 94 is 97. So it's close to being 90, but it's not. So those are not perpendicular to each other. So that's lesson 7. Let's look at lesson 8. And again, if you need to pause it to copy anything down, please pause it, and I will do a live video to see if there's any questions on this. So this one is the wee. So the whole thing is 14. I have to add the 8 and the 6 together. And the whole thing is x, and that external part is 4. So it's always the whole times the external, that's the part sticking out of the circle, equals the whole times the external. I'm just multiplying and solving for x, and I get x equals 21. Again, 2 is also the wee, except I have a tangent, which I'm trying to find out what that PA is. The tangent is x, that's the whole thing. It's also the external part sticking out of the circle, so it's actually x squared. On the secant, the whole thing is 16, and the external part sticking out of the circle is 4. 4 times 16 is 64, and I'm solving for x, and I get x equals 8. Here I have 2 secants. I had to draw this picture myself, but I have 2 secants, and again it's just the whole thing, which is 24, times the external part, that's the part sticking out of the circle, equals the whole thing, which I have to add these together, is x plus 12, times the external part, that's the part sticking out of the circle. You're distributing that 12 to everything inside, so I get 12x equals 96, because I subtracted 240 minus 144, and then I divide by 12 and I get x equals 8. This is another one that I need to draw. I have a secant and a tangent. So the tangent is 14. The tangent is 14, that's the whole thing, and it's also the external part, so I'm really just squaring that tangent. The whole thing is x plus 4 for the secant, and the external part sticking out of the circle is 4. I distribute that, subtract 16, and divide by 4. Solve, I get x equals 45. Okay, and then the second page, we're just looking at 5 right here, which has a couple of parts to it. The first thing I want to do is I want to find the length of BC. So BC is right here, that's my x. I'm going to use that whole, so this is my whole thing is x. The external part is x, so x squared equals the whole thing over here is 8. I'm adding the 6 and the 2 together, and times the external part is 2. So x squared is 16. I take the square root of x, and x is 4. Now here on B, I want to find the length of that radius. Remember, a tangent and a radius form a right angle, so I'm going to use the Pythagorean theorem. So I have 4 squared plus b squared, so this whole thing is b, equals, and this is my hypotenuse, the whole hypotenuse is 8. 8 squared is 64. I subtract 16 and I get 48. I'm taking the square root of 48, which I want it in simplest radical form. So radical 16 times radical 3 is radical 48. And the square root of 16 is 4. So I get 4 radical 3. Now that's actually my diameter because this was the whole thing AB. And I want the radius, which is half of that. So half of 4 radical 3 is just 2 radical 3. When I want to find angle C, which is part C right here, I'm actually not going to use my circle theorems. I'm going to use trig because remember, this is a right triangle. So I'm trying to find this angle. This is 4, and that's adjacent. 8 is my hypotenuse. So when I have adjacent and hypotenuse, I'm going to use cosine. So cosine of C is 4 over 8. And remember, when I'm trying to find the angle, that's when I use that inverse button on my calculator. So cosine -1, 4 divided by 8 is 60 degrees. And then when I want to find the measure of arc AD, so arc AD is right here. I'm actually going to do, this is 180, that's a complete circle right here. And I know that this angle is 60. That's an angle that's outside the circle. So the angle is 1/2 the difference of the arcs. So 1/2 of 180, and I'm trying to find this arc right here. It looks like I called it Y, but I might have written X here by mistake. But to get rid of that 2, to get rid of the 1/2, I'm going to multiply by 2. 60 times 2 is 120. And then I'm solving for X. So I am going to get X is 60 right here. And I want to find arc AD, which was right here. So this is half a circle. So if this is 60, then 180 minus 60, that's actually going to be 120. And you didn't have to do that last part. So that's the end of this. And again, I will take any questions if you want to go on YouTube to watch it live at 12 o'clock tomorrow.